Now, before we finish up talking about the JavaScript engine, we need to talk about the event loop. Up to this point, we have established that JavaScript is single-threaded. It only has one call stack. It can only do one thing at a time, so it is synchronous. However, JavaScript allows us to do asynchronous coding. A simple example of that is adding a button to an HTML page. We can be running some JavaScript, the user will click the button, and we can respond to that click. Because we have JavaScript running, doing something else, it doesn't block the user from clicking that button. That would, of course, be a horrible experience on a browser. Another example is if we are trying to fetch some data from a database. We make that call to the database, and then we can do something else while we're waiting for the data to return. We don't have to sit and wait for that data before we do something else. That would block other JavaScript processing. We can do something else, and then when the data returns, we can act on that data. We can achieve this asynchronous coding in JavaScript because of the event loop. In the previous scenario, the set timeout command was handled by the web API, and I mentioned at that point the JavaScript engine forgets all about it. Well, once that timing event is done, once the web API finishes that timing event, how does that get integrated back into the call stack so that the task we want completed gets done? For example, if you remember, we have a callback function as a part of the set timeout. How does that callback function get back to the JavaScript engine? Let's walk through that previous scenario again, but this time we will include the event loop. Once again, here's our code. Here's our set timeout, and notice we have a function here. All the function has within it is a console log statement. That's all. The milliseconds are set to 0, so the timer should expire immediately. But let's see what happens. We've gotten to the point where the hello world function is invoked. So let's continue to walk through that. So we have the invocation of the hello world function that is added to the call stack. And then it begins working through the commands inside that function. And so the first command we encounter is a console log statement, and it's going to log variable a to the console. And so that's added to the call stack. It takes care of that log statement. We see hello on the console, and then the console log command is removed from the call stack. And then we move along in that function. We encounter the set timeout. Now, the JavaScript engine knows that set timeout is handled by the web API, so it is sent over there to be dealt with. So the web API sets up a timer. It has the ability to run a timer. And that timer expires immediately because we have it set to 0 milliseconds. And so when the timer expires, what does it do with that callback function? That's the thing the timer is supposed to do. And so what it does is it adds the callback function to the message queue. Now, that callback function will sit in the message queue. And it's at this point the event loop comes into play. The event loop will continue to cycle. It will be checking the call stack and see if it's empty. Right now, it's still working on the hello world function, so it is not empty. But it cycles and continues to look, seeing if it's empty. If it's empty, it would then add the next item available in the message queue into the call stack. But right now, it's not empty, so we need to continue with the hello world function. And so what's the next thing that comes up? Well, it's another console log statement. So that gets added to the call stack. And we go ahead and complete that console log statement. World is printed to the console. And so that console log statement is removed from the call stack. At this point, we are finished with the hello world function. And so that is removed from the call stack as well. So as I mentioned, the event loop is cycling and checking the call stack. So it checks and sees that it's empty. It then grabs the next item in the message queue and adds it to the call stack. And so we get that anonymous function, that callback function, out of the call stack. And it begins to work through what that function needs to do. The only thing in it is a console log statement. It encounters that console log statement and adds that to the call stack. The console log statement is completed. An exclamation point is printed to the console. That's removed from the call stack. That is the end of that function, and so that function is removed from the call stack as well. And so at this point, the call stack is empty. There's nothing left to add from the message queue, and so we're simply waiting for another JavaScript command that needs to be executed. All right, now before we're done, let me just highlight some important points from this discussion. First, other parts of the JavaScript environment can handle certain tasks. For example, those tasks that belong to the browser. The JavaScript engine doesn't have to process those. We, in this example, use the web API to handle that set timeout command. But the callbacks that are a part of what is handled there are integrated back into the engine using the event loop. It pulls them from the message queue and adds them to the call stack. We achieve asynchronous JavaScript this way. The event loop is critical in making that happen. Another important point, once a callback is added to the call stack, the code is handled by the call stack as it normally would be if the JavaScript code had not come from the queue. Doesn't matter. It's going to process that JavaScript in the same way. Next, a reminder, the event loop is constantly checking for items in the queue and if the call stack is empty. If the call stack is empty and there's something in the queue, it will add the next available item from the queue into the call stack. And as mentioned, the call stack is one thread. So it is synchronous. It can only do one thing at a time. But its interaction with the event loop and the web API allows the asynchronous coding that we can achieve in JavaScript. All right, let's move on to the next topic.